Hello lovelies, in this video we're going to be looking at the future of mineral supplies for environmental science. Now don't forget, Prim over there doesn't want you to forget that once you finish doing this you can go over to the website where there is a free set of questions, free set of flashcards to help you revise everything in this video.
Lesson 18. The Future of Mineral Supplies. We know that Lasky's principle states that as ore purity decreases, the volume of ore present increases exponentially. So for the future of mineral supplies, we're going to have to get better at extracting and using these low grade and low purity deposits, as that is where the majority of the remaining ore is. Smelting. Usually, to extract metals from their ore once we have mined them, we could use a process called smelting, where high temperatures are created which chemically reduce the ore. The energy needed for this process increases exponentially as the grade and purity of the ore decreases, which would increase the cost. This means that the process may not be economically viable when extracting from lower grade deposits, so a new process may be required. The energy usually comes from the combustion of fossil fuels too, so is quite a damaging process for the environment, releasing greenhouse gases and contributing to global warming. Spoil heap. One example of a low-grade deposit that we could extract from is spoil heaps. Remember that spoil heaps are the waste products from mining for ore, for example the overburden. The spoil waste will contain small amounts of mineral ore that we can try and extract. The first method we can use to extract from spoil heaps is called bioleaching. This process uses a fungi or bacterial species that have enzymes that allow them to oxidize sulfide-containing ores to release sulfuric acid. The bacteria or fungi are grown on the spoil heap, and when the sulfuric acid is released, it can percolate through the spoil and dissolve any metals contained within it. This is because metal solubility increases at lower pHs. The fluid can then be collected and the metals are separated out using electrolysis, an electrical current passed through. Phytomining is a process that uses plants to extract metals from low-grade ores such as spoil heaps. When plants are grown on the spoil heap, they absorb the metal ions through their roots and accumulate them in their leaves. Once the plants have grown, they can then be harvested and are incinerated to create an ash that will have concentrated the metal ions. An acid can then be added to the ash to dissolve the metals, which can then be extracted from the liquid using electrolysis. This process involves the combustion of organic matter, so we'll release carbon dioxide into the atmosphere, enhancing the greenhouse effect. Another way that we can obtain minerals from a spoil heap is by collecting the leachate that naturally forms as rainwater percolates through the spoil. The rainwater will dissolve metal ions and will become acidic. Once collected, the leachate can undergo electrolysis to separate the metals. We will now look at some methods used to extract minerals from other low-purity deposits. The first is polymer adsorption. A polymer is a long-chain molecule, and absorption means to stick to a surface, so this process involves using long-chain molecules that mineral ions will attach to the surface of. This is used to extract metal ions which are dissolved at trace concentrations in seawater. This process can use natural polymers or synthetic ones. Once the polymer has been left in the seawater for a set amount of time, it can be removed, and the concentrated ions will be washed off and collected. This process is currently being used to extract uranium from seawater, which can then be used as a fuel source for electricity generation in nuclear fission. Another way in which we can extract minerals from low-purity sources is using displacement reactions. This is based on the principle, if a metal is more reactive, it can displace a less reactive metal. An example could be where the low-purity deposit could be a solution containing copper sulfate. If you add iron, which is more reactive, the copper will precipitate out of solution and can be collected. You just need to remember the more reactive metal would displace the less reactive one. Of course, this process relies on us using another metal to extract the new one, which may not always be available. Whilst there are lots of options we can use to extract minerals from low-grade ores on the Earth's surface, sometimes the deposits will be deep underground and hard to access. Consequently, we also need to improve our machinery and technology to help us access them, including using bigger and stronger machinery. It would also be beneficial to completely mechanise deep mining so that people do not have to go deep underground, which can be highly dangerous. Finally, something else we can do to secure future mineral supplies is exploit previously inaccessible deposits. One example of this is extracting manganese from nodules found under the seabed. The nodules contain high volumes of manganese, as well as some other metals including copper and nickel. Extracting this metal will be expensive, as it will require technology to extract the metal properly and recover it from the ocean. The extraction will also depend on which countries own which sections of the seabed, and therefore allowed to mine there. Permits may be required. This process will completely disturb the seabed and destroy benthic, the bottom of the ocean, habitats such as deep water coral reefs. Finally, another important aspect of securing future mineral supplies is applying initiatives from the circular economy model. Cradle-to-cradle design is where a product is designed with its end of life in mind. It means that when the product needs to be recycled, it is easy to do. For example, it is easy to separate and identify the different components so that they can be reused or recycled accordingly. If we can extend the useful life of the minerals we have already extracted, then it will reduce the demand on extracting more. A huge part of doing this will be recycling. In your exam, you will be expected to be able to give advantages and disadvantages of this process. Advantages: conserves mineral resources we have already extracted, reduced energy use in mining, reduced environmental impacts of mining, and reduced waste disposal, so less going to landfill. Disadvantages: some materials cannot be separated, so cannot be recycled. Some recycling processes reduce the quality of the product, so can only be recycled once or twice. Fossil fuels are used to power collection trucks, and it relies on consumer cooperation to properly separate their waste, which doesn't always happen.
Ouch! This is why in some videos I'll explain scratches.